What I've started to do here is marked off the height. I've worked out the total height to be 70. Okay, so the maximum displacement of 70. So I've marked off here where it says there was a rise of 20, and I've marked off 25 and 50 to give me the total height of 70. On this side they tell us that the total length is 130, so I can mark that off. And the problem with that is that distance is not divisible by 12. So we're going to have to do the line division method to get our splits here. So let's remember the process. We are going to take our line here and mark off 12 equal measurements. Line up the last point now, and then project those lines down to get the remaining points. I've labeled my displacement graph. I've put in my horizontal scale, so 130 millimeters to the 360 degrees. My vertical scale is 1:1. I've done my line division construction to get my equal splits, and we're going to probably be doing the same for the vertical part for the uniform acceleration and retardation. But let's do what we can so long. The follow rises for 20 mils over the first 60. There was my height of 20 and 0.60. Then it says over the next 90 degrees of the rotation, it rises 50. So there's 30, 60, 90. So what is the problem here? Is that that's only given us 3 divisions, and we know we need 6. So we obviously have to find the center of that distance, roughly about 5. To find the center of these splits. So this is for my simple harmonic motion. There are the points. We know that it's rising 50. My apologies, let me just go back here. There's a dwell period for 30 degrees. So I've mixed that up here. So there's my dwell period. Then I've got 30, 60, so it needs to go up to here is my simple harmonic motion. Remember, there's got to be 6 vertical divisions and 6 horizontal divisions. Let's draw in the semicircle to put in our pizza slices. There's my semicircle, put in my pizza slices. As we've done before, we could label them 0, that's not necessarily the true measurements here. So if it was 0 and 0, the next point away from there I'm calling my 30, even though it's not the angle. There's 60 to the next one. This one we've already got. there were our points. We can now join those up. I've joined up my simple harmonic motion. Remember, that's a very similar method that you would use if you were drawing a helix. So the last part of this is where it falls to the original position, so at the bottom, over the next distance. So if we just check there, we need 6 divisions. 1, 2, 3, 4, 5, 6. Yes, we've got 6 divisions, so they'll be on these vertical divisions. We need to find the center one. So if you wanted to, there's our center at 3. And now we need to mark off the vertical heights. What you could do differently from the other one is we could do your line division construction on the center line here, so we don't have to transfer anything. There are my 6 heights. We now need to project them. The last one goes to my highest point at 3. Then slide your set square down. And there are our vertical heights. Now remember, if we label our vertical heights, what we need to remember is that the line going from the corner through 3 should give us a diagonal going through these points, and should be a test for the accuracy of your drawing. So there, mine has gone through there, so I'm happy with that. Let's line up the points now. So for the top part, the acceleration, I'm taking my corner to the first height. Where it intersects with the first point gives me my point. I take from the corner to the second height. Where it intersects the second line is my point. The third point is the midpoint of everything. Then we do the retardation side. So we come down to the bottom here. That corner we project to the 4th height, where that intersects the 4th vertical line. We join it up. Next, our 5th height, where that intersects our 5th line, and there is our last corner. So remember, when we've got our uniform acceleration and retardation, the start point, the center, and the bottom point you should always be able to find. So that should be a given to get those points. Much like we've done before, let's join them up. Those middle 3 lines should line up. Then we've got a slight slope change, and then do our curve at our last point. Here we've got that little change, and let it curve down into the bottom. And there is the end of our drawing on page 115. What's my page 115? Question B, showing uniform acceleration and retardation, simple harmonic motion, and uniform acceleration and retardation.